Okay, let's have a look at this concept of weight. And we're distinguishing it from the concept of mass. It's often a confused, or they're often confused terms. So mass we define as the amount of substance that we have. So the amount of protons, electrons, neutrons, which form our atoms. And typically that is unchanged unless we add mass to it. Now that's often confused with weight. So let's explore what this concept of weight is. To do that, we're going to do a little thought experiment. So we're going to put an object in a vacuum, and the only force that's acting on that object will be the force of gravity that's pulling that object down. Now, Newton first had a look at this, or first explored this, and he found that all the objects, the objects that he dropped in his experiments, they all moved with the same speed. So what he came up with as his concept was that there was an increased force each time, so there was a bigger force of attraction, but if we had an increased mass, this ratio stayed the same. And this was his observation, was the acceleration stayed the same, therefore the force must increase, or the force of attraction must increase to an increased mass. Now we can use this equation to help us with our exploration of weight. So let's go back to our experiment. The net force in this case is equal to the force of gravity. So if we substitute from above for our force, we find that our net force is going to be equal to our mass times our acceleration experienced by the object that's undergoing that force, which will be equal to our force of gravity. Now our acceleration is going to be equal to acceleration due to gravity, so we can substitute for this term g. So if we rearrange with our force of gravity on the left-hand side, we get that the force of gravity is equal to the mass of the object times the acceleration due to gravity. And remember up here we said that Newton observed that this acceleration due to gravity was constant. So we can say that weight is the force experienced by a mass under the influence of gravity to give us a constant acceleration. Now we can also use this concept of weight to find the mass of an unknown object. So if we have a known object A and an unknown object B, we put them onto a scale. We can keep adding known mass or known mass or take it away until we reach an equilibrium point where both of these objects are at equilibrium and not rotating. Now at that point, we know that the force experienced by this object is exactly the same as the force experienced by our known object. So we can use our equation as above. Our force of gravity will be equal to our mass times our acceleration due to gravity. And on the left-hand side, we've got our force experienced by the object. Because it's in equilibrium, will be the force experienced by our B object. So we can substitute in, and we find that our acceleration due to gravity will be exactly the same on both sides. And what this then gives us is, if we know the mass of our object on the left-hand side, it's going to be equal to our mass on the right-hand side. In other words, we can quite easily calculate our unknown mass.